All right, this is 1.7, 1.14 study guide. Let's start with the multiple choice. So all of this that I'm about to go over, please make sure that you're not using calculator, okay? All right, number 1 through 5, find the equation of the horizontal or slant asymptote for each of the functions. So quick review. Horizontal asymptote goes this way, right? So usually it's like a y is equal to something. In order for you to know that, you gotta know that, check the degree of the top and degree of the bottom. So 3 cases. When degree of the top is bigger, when degrees are the same, or when degree of the bottom is bigger. So let's look at each one at a time. Number 1, check the degree. The top, the numerator degree is 1. That's the exponent. Denominator, the degree is 2. So it's bottom heavy. When it's a bottom heavy horizontal asymptote at y is equal to 0. Don't say 0. You have to say y is equal to. Number 2, it's already in the standard form. Degree of the top is 2, degree of the bottom is 2. So they're the same degree. In that case, horizontal asymptote is y is equal to the leading coefficient over leading coefficient. In this case, y is equal to 5. Keep going. Number 3, degree of the top is 2, degree of the bottom is 1, linear. So it's a top heavy. Folks, when it's a top heavy, where is horizontal asymptote at? None. It does not have a horizontal asymptote. Instead, it's going to have a slant asymptote. So slant asymptote means not the horizontally, it's going to be like slanted. Kind of like a, sometimes linear, sometimes quadratic, it depends. How do you find the slant asymptote? You're going to divide that by that. So you're going to actually go ahead and divide it. And when you do that, I'm going to use a box method. So let's set up. On the left column, your divisor goes in. So 5x and plus 4 goes there. Okay? And whatever goes inside of a box over here has to match this with your dividend right here. Okay? All right, so let's fill it in. The largest exponent is a negative 20x squared, so you put that right here, negative 20x squared. Because whatever inside over here has to match it with that here. All right, the area of this box should be 5x times what? 5x times what gives you negative 20x squared? Negative 4x. So negative 4x goes there. How do I find the area of this box? Wouldn't that be the 4 times negative 4x? Negative 16x. Whatever inside of here has to be same as your dividend. Right now I have a negative 2x squared. Yes. I have only negative 16x. What do I have to add to negative 16x to get to negative 21x? Wouldn't that be another negative 5x? So you put that number right here. And now work backward. 5x times what gives you negative 5x? Negative 1. All right, and I'm going to stop because I did all I have to do. Remember, your slant asymptote is the quotient of this divisor problem. So y is equal to quotient negative 4x minus 1. That is your slant asymptote. That's not the function. That is your slant asymptote. So I know the question didn't ask you, but that means, folks, for this rational function, your asymptote is going to look like that. I don't know what the actual function looks like, but that's what it's like. Okay? All right. Number 4, you can't really see well. So 1 and 2 and 3 are all in standard form, so it was really easy to find the degree. But number 4 and 5 and 6, wait a second, what's going on? It's not focus. There we go. 4 and 5 is, well, 5 and 6. 4, particular, that's in the factor form, meaning we can't find what the degree is yet. So we're going to pick and choose the one that's going to give you the largest exponent. So for this case, it's going to be x times 2x squared. Let's see, x times 2x squared, wouldn't that be x times 4x squared, 4x cubed, plus, I don't care about the rest. All right, what about the denominator? Same thing, you're pick and choose the one that can give the largest exponent. What is 4x squared? 4x times 4x is 16x squared, plus, I don't care about the rest. Okay, so now you can find the degree of the top and the bottom in the standard form. Degree of the top is 3, degree of the bottom is 2. So wouldn't that be the slant asymptote? Well, first of all, horizontal asymptote, none. So you're going to look for the slant asymptote. Give me 1 second. Sorry about that. I was just checking the key of what Mr. Bear did. It looks like, so it's going to, since the degree of the top is bigger, top heavy, we know it's going to have a slant asymptote. He made a note that you don't have to actually find out what it is, because in order for me to find slant asymptote, I have to FOIL it all out. That seems like a lot of work. So just note that it has a slant asymptote. Number 5, keep going. Degree of the top 2, degree of the bottom 1. It's a top heavy, so it's going to have a no horizontal asymptote again. We're going to have a slant asymptote. So let's do the division. Just like number 3, we're going to use a box method. So if I were you, and if I struggle with the box method, I'll probably pause this video. Make sure you try this one first. Okay? All right. So divisor x minus 4 goes over here. Whatever goes inside a box has to match it with my dividend. My dividend is 5x squared. So I'm going to put that over here. 5x squared. All right. X times what gives you 5x squared? 5x. Negative 4 times 5x is negative 20x. Whatever inside of this box has to match with their dividend. Right now I have a negative 20x. I need negative 8x. So what do I have to add? 12x. So you put 12x over here. So when you add this up, it becomes negative 8x. Well, if that's a 12x, x times 12 is that. So my slant asymptote is at y is equal to your quotient, 5x plus 12. Okay. All right, number 6. Ooh, this is a little tricky. Be careful here. Because if I want to be careful, I was just going to say degree of the top is 4. Right? Because that's the largest exponent. But do you actually see over here x to the 4th power minus x to the 4th power? They cancels out. So really, numerator, I'm only left with a negative 3x squared. Ah, that was tricky. And denominator, I'm going to write it in the order. So negative 5x squared plus 2x plus 3. You see how that's larger exponent than the 2x. So I put it in that order. All right, degree of the top is 2. Degree of the bottom is 2. Same degree, so horizontal asymptote is y is equal to leading coefficient over leading coefficient. Folks, that is y is equal to 3/5. Okay? All right, let's keep it going. The number 7 through 9. Find x variable 0, whole, and the vertical asymptote. Got it. All right, so when I look at it, first thing, I want to find the canceling factor because that's the most confusing one. Well, notice over here I have an x minus 4, x minus 4. So it is canceling factor, but after I cancel out, I have things left at the bottom. Okay, so when you cancel, you're like, ooh, it's a whole. But no, because you have things left at the bottom. So what will that give you? That's going to be the vertical asymptote at x is equal to 4. What else going on? Do I have any non-canceling factor of denominator? Nope, so that's the only vertical asymptote. What about this 4x? Non-canceling factor of the numerator. I'm going to set that equal to 0. I get x is equal to 0. What would that be? Wouldn't that be your 0 of the function? So you got 0 at x equals 0. Vertical asymptote at x equals 4. No whole. Let's keep going over here. Ooh, canceling factor x minus 5. But after I cancel, I have things left on the top. So what would that x is equal to 5 be? After I cancel, I have things left on the top. That's going to be a whole. Yeah? All right, what about x plus 5? After I cancel, I have things left at the bottom. So that's going to be vertical asymptote. Didn't we do the exact same example on the top over here? Right, the x minus 4. After I cancel, I have things left at the bottom, vertical asymptote. After I cancel, I have things left at the bottom, vertical asymptote. After I cancel, I have things left on the top, whole. Okay? And then doesn't appear to be any 0. If you're really, really curious, because some people thought, Miss Major, that x minus 5 is on the top. Wouldn't that make it a 0? Alright, technically this whole is going to be what's called a fake 0. So like it's going to look like this at 5, like this. Like it's a whole, but it's on where it's supposed to be the 0 is. So we're still going to call it a whole. We're not going to call it a 0. But if you're really curious, that's what's going on. Number 9. Ooh, let's see. X plus 4 is a clean canceling factor. So that's going to be whole. X is equal to negative 4. Yay? Alright, what about this x plus 3? X is equal to negative 3. Non-canceling factor of the denominator, that is your vertical asymptote. What about this? X is equal to half. Non-canceling factor of the denominator, that is your vertical asymptote as well. Do I have any 0? I do right here. Boop. X is equal to negative 6 is the 0. So you have two vertical asymptote at negative 3 and x is equal to half. 0 at x is equal to negative 6. Whole is at negative 4. What about this negative 4? Nothing. Okay, that negative 4 equal to 0 makes no sense. So there we go. Use the graph below to answer the question 10 through 17. So these are all limit statement. All right, number 10. Limit as x goes to negative infinity. Folks, I'm talking about the far left end behavior. But if you look at this rational function, as I go to the left, where are we going to? Where are we approaching? Wouldn't you agree that it's approaching the horizontal asymptote? It's going to get closer, closer, closer to that point. which is what? At y is equal to 1. So limit as x approaches negative infinity is going to go to 1. Hint, hint, that's your horizontal asymptote. All right, number 11, as x goes to positive infinity, this time you're going to the right, farthest to the right. What y value is it approaching to? Well, there's an asymptote, so when it approaches to 1 again, horizontal asymptote. So reminder, for the rational function, left end limit, right end limit, both go to your horizontal asymptote. Number 12, x is approaching to negative 1 from the left. Okay, so I'm going to put my, it's too thick, but that's the only thing I have, okay? I'm going to put my pencil at negative 1, but where is it coming from? It's coming from the left. So it's coming to negative 1 from the left. Where's negative 1? Negative 1 from the left. What y value is it going to? Negative infinity. Number 13, x is going to go to negative 1 from the right this time. Plus on the right top polynomial is coming from the right. So there's negative 1. I'm going to put my pencil here. This time it's coming from the right. Where is it going to? Positive infinity. Why is this happening? When it's coming from the left, it goes negative infinity. When it's coming from the right, it goes positive infinity. Why? Because there is a vertical asymptote. All right, this time x is going to go to 1 from the left. Where's a 1? Ooh, there's a hole there. So x is coming to 1. To the 1 from the right. What y value is going to? Y value is the 2. Mrs. Major, there's a hole, so it's nothing there. Correct. Remember, the limit doesn't care what's there. Limit only cares what is going to. It's going to 2. All right, then x is going to, number 15, x is going to go to 1 from the right this time. It's going to the y value of the hole again. That is a 2. So that's what's happening for the limit at hole is it's going to go to y value of the hole. Number 16, between negative infinity to negative 1, which statement of the f is correct? So we are talking about, where are you? Here to here. This right here. All right, I'm talking about the f. Is f increasing or decreasing? F is the function, the y value. So from here to here, y value is decreasing. It's going down. At decreasing rate means concave down. At increasing rate means concave up. You tell me from here to here, does it look like concave up or concave down? That's a sad face, concave down, letter A. Next, write a possible factor form of the function based on the characteristic of the graph shown. Okay, I got it. I'm just going to do it over here so you can see better. All right, let's start with the vertical asymptote. The vertical asymptote was at x is equal to negative 1. Wouldn't factor form be x plus 1? And where's the vertical asymptote go on your factor form? Denominator. There we go. I'm just making the most simplest one. All right, where's the hole? Hole is at x is equal to, 1. Factor form, x minus 1. Ooh, are you guys okay if I put the top and the bottom? Canceling factor. Next, what else do we have? 0? Ooh, 0 is at negative 3. 0, x is equal to negative 3. Factor form, x plus 3, and I'm going to put that on top. Clearly, there are other things I can do. For example, I can actually figure out the y value of the hole and then put that in account. Horizontal asymptote is that y is equal to 1, so leading coefficient over leading coefficient. Actually, that one does work. However, I have it right now. Okay? So I'm just going to leave it like that. It's good for now. Okay? All right. I'm going to stop this video and start the next one for the later ones.